Welcome to another edition of Crimes Notes. At this point, we've done all kinds of solving to variables on one side, variables on both sides, combining like terms, distributing. So the last thing you need to know about solving is these special cases. As usual, you have your 3 warm-up problems up here at the top. You do those on your own, and then I can check those. So let's dive right into the vocabulary that you're going to need for today's lesson. The first thing that we're going to learn about today is no solution. The second thing we're going to learn about is infinite solutions. So these are 2 things that can happen whenever you are solving. So when we're talking about no solution, the first thing that you need to know, or your first bullet point, is that the variable has to cancel out. And I know you don't really know what that means right now, but we'll talk about it. So the variable has to cancel out. Okay. And we can also go ahead and write that same thing for infinite solutions. Okay. The only way that this could happen is if the variable cancels out. Has to cancel out. So that's your telltale sign that the answer is either going to be no solution or infinite solution. So then what's the difference? Well, no solution means that you get a false conclusion. Meaning when you look at the answer after the variables cancel out, it has to be false. So in other words, it would say 2 equals 6, or it could say -5 equals 5. Again, those are not the same, therefore it's not true, which makes the answer no solution. And then the other part is to write no solution, you do a circle with a line through it, or you can actually write no solution. It kind of looks like a no smoking sign, okay? For infinite solutions, the variable still has to cancel out, but this time you get a true conclusion. Okay, that means once you remove the variable and you get to the bottom, you should get 6 equals 6, or -5 equals -5. And then to do infinite, you draw the infinity sign. To me, it's just a sideways 8. I'm not very good at drawing it, so I will usually just write infinite solutions. But that is the symbol, if it's easier for you to write. So what I want you to do is look at some of these and see if we can't figure out whether or not they're going to be infinite, no solution, or regular solution. So for no solution, I'm going to use pink. Okay, you can use whatever color you want. For infinite solutions, I'm going to use blue. And for regular solutions, I'm going to use orange. And I'm not going to do all of them for you, but we will look at some. Okay. So for certain, I think you guys can do this one and this one, since I just drew those symbols for you. Okay. But the ones that I want to help you with are the problems. Okay. What I want you to notice is that if you have the exact same variable on both sides, so once you've put all of your variables together, you get 2x plus 3 equals 2x minus 4. Well, it's both 2x and 2x. These 2 things match exactly. So if I went to move this over, I would have minus 2x minus 2x. Those 2 things are going to cancel out. So what I'm really comparing here is 3 equal to -4. Well, are those 2 things equal? Absolutely not. 3 does not equal -4. That tells us that this one would come out to be no solution. So now look at this one. We have 3x minus 1 equals 3x minus 1. Those are identical. So that's the same thing as saying 0 equals 0, or 2 equals 2, or 6 equals 6. So that would be infinite solutions. So if they're completely identical, it's infinite solutions. If they're exactly the same except for the constants are different, then that's going to be no solution. If neither one of them are the same, so we have a different x and different numbers, that's just going to give you a normal answer. So if you solve that, you would get x equals some number. Okay? So those are the 3 that I wanted to help you with. These other ones, I want you to highlight and match your colors and figure out how those work. Okay. So now let's look at the mathematical examples and see what this looks like in those terms. All right, so let's look at number 1. Again, we're still going to follow our steps, so we're going to draw the line. Our next step is to distribute to remove parentheses. So this times this, and this times this. So I have 3 times 2, which is 6. 3 times 1v, which is going to be positive 3v. And then I would just bring this down, so I have minus 4v equals, and then I would bring this down because I didn't do anything. Next, I'm supposed to combine like terms. So on this side, the 3v and the minus 4v go together. So 3 minus 4 is negative 1. So I have 6 minus 1v. And then on this side, I have positive 1v plus 16. Now I put the 1 just to show you. So if we were looking, are the v's the same? No. I have a negative 1 and a positive 1. Are the constants the same? 16 and 6. No. So this is just going to be a normal problem. So I'm going to move my variable to the left. So minus 1v minus 1v. 1 minus 1 does make 0, so those cancel. I bring down the 16. I bring down the 6, and then negative 1 minus 1 is minus 2v. Now I would put my constants together, but again, opposite sides, so I have to do the opposite. So minus 6, minus 6. I would bring this down. Minus 2v equals 10. Sorry about the vibration, guys. My phone keeps going off. Divide by negative 2, and I get v equals negative 5. So again, our telltale sign, the v's were not the same and the constants were not the same. So this one ended up being a regular solution. So this whole problem was regular. So now let's look at number 2. Same thing, we're going to draw the line. I'm going to start by distributing. So 2 times g is 2g. 2 times negative 2 is negative 4. And then I bring this down, so minus another 4. On the right-hand side, I do 2 times g, which is 2g. 2 times negative 3 is negative 6. We combine like terms on this side, so I get 2g. Negative 4 minus 4 is negative 8. This equals 2g minus 6. At this point, if we compare, you should notice that the 2g and the 2g are exactly the same. The only thing that's different is the negative 8 and the negative 6. So we should automatically know that this should come out to no solution. But I want to work it out so that you guys can kind of see what happens if you don't notice it, okay? Because it's not a big deal. So just like normal, if I went to subtract, minus 2g minus 2g, what ends up happening is 2 minus 2 is 0, so that cancels out. That leaves me on this side with a negative 6. On this side, 2g minus 2g cancels. So I bring this down and I have negative 8 equals negative 6. Well, is that true? No, and I don't have a variable. So the variable canceled out and I have a false solution or a false conclusion. So your answer here, okay, is actually no solution. And again, if you notice it at this point, I'm okay with you automatically putting no solution as long as you circle this and you tell me that it's no solution. Okay. All right, so let's look at the last one. By process of elimination, you can probably tell that this one is going to end up being our infinite solutions. Okay, so this is going to be our example of infinite solutions. Okay, but let's go ahead and start with our line. So we draw our line down the middle, and then we're going to distribute. So 3 times m is 3m. 3 times 5 is 15. I bring down the minus 6. Same thing, we would distribute on this side. So 3m, and then 3 times 3 is positive 9. If I combine like terms, 15 minus 6 is 9. So I have 3m plus 9 equals 3m plus 9. Well, at this point, if we compare, we have the exact same thing on the left side as we have on the right side. That basically tells us that it's infinite solutions. But if we didn't notice and we tried to solve, minus 3m, minus 3m, these variables are both going to cancel out, and when I bring this down, I end up with 9 equals 9. Well, that is a true conclusion. So that tells us that this is infinite solutions. Okay, so again, the answer here is not 9 equals 9. The answer is infinite solutions. So this is what I need to see, either infinite or the symbol. And on the no solution, I can't see this as an answer. I have to see no solution or this symbol. Okay, good. And please remember, x equals 0. Let's put this on the notes to self. X equals 0 is an answer. Okay, if you get x equals 0, that is not no solution or infinite solutions. Okay, x equals 0 is an answer. So is x equals 1. Okay, that is also an answer. The only way to get no solution or infinite solutions is for the variables to cancel out. All right, I hope this kind of made it a little bit clearer for you. Good luck, and if you have any questions, just ask.